Okay, so I'm going to start with yesterday's IXL, which is geometry S.11, and I'm just going to do some example problems from it. If you already have yesterday's IXL done, you don't have to pay attention to this part right now. I'm going to do a few examples from S.11 and record that, and I'm going to do a few examples from today's IXL, which is T.10. So today's IXL is geometry T.10, and you also have to get to 80. Okay, so I'll do a few examples from both. Feel free to kind of tune me out and just be working. And then if you have any questions, once I'm done with going over these examples, I'm going to stay on here, and you guys will obviously stay on for the duration of class, and I can go over any questions you might have, just so we're all ready for tomorrow's quiz. All right, so this is S.11, which is titled area and perimeter of similar figures. This would have been equivalent to our section 2.6 homework that was due yesterday. It says the figures below are similar. The labeled sides are corresponding. What is the perimeter of the larger triangle? So the side length ratio from the first triangle to the second triangle is 6/9, which reduces to 2/3. Sorry, writing on IXL is not the same as writing on Notability. So it's not as smooth. You probably know that. Okay, so there's the side length ratio. I'll say SL for side length. We know that the perimeter ratio is exactly the same. So the perimeter ratio is also going to be 2/3. Okay, so that's the perimeter ratio. So I'm going to set up a proportion. When it says the perimeter of the first triangle is 16, I know that 2/3, which is my perimeter ratio, has to be equal to, go back to the first triangle, 16/x. And you can cross multiply that, or some of you might have realized on an example like this, you might have been able to use mental math. And I know many of you guys are smart enough to do that. And so you would have noticed that 2 times 8 gives us 16. And so if you just do 3 times 8, you'll get 24. And that's the answer you would have gotten if you use cross multiplication. Okay. Here's an area one. Good. I wanted to make sure I hit both of those, perimeter and area. So for my side length ratio here is 2 from the small triangle. I'm just going to go left to right every single time. And then 4 for the big, I think I said triangle. It's 2 from the small square, and then 4 from the larger square. And that side length ratio is going to be reduced to 1/2. So there's my side length ratio. Now I know that my perimeter ratio is equal to my side length ratio. So I know the perimeter ratio would also be 1/2 here, but I don't want the perimeter ratio. I want the area ratio, and the area ratio is equal to the square of the side length ratio. So my area ratio would be 1/4. So I'm going to set up a proportion that says 1/4 is equal to, and then they give me the area of the small square. So I'm going to put that on top because that's where the 1 came from. It was reduced from the 2. So I went left to right. I'm going to go left to right again, 4/x. And so when I cross multiply this, 4 times 4 is going to give us x, and that's going to be 16 square yards. And that's really the 2 different types of problems. Eventually, if I do enough, I'll get to ones, maybe, this isn't one, where they give me, instead of giving me both side lengths, they're going to give me both perimeters and ask me what the side length ratio is. Or maybe they'll give me both areas and ask me what the side length ratio is. So I'm going to try to find one of those. Maybe if I go to online, I'll have a better job. I'll do a better job of finding one. So give me a second here. That way I'm not doing the same problems over and over, because you probably already have a score that's past 19. No. Okay. So let me stop sharing my iPad and I will share my computer screen. So here's another type of problem that you might see. I'm in the 70s right now on my computer. So when you get that high, you might see one like this. It says, look at the parallelogram. If both dimensions are tripled, then which of the statements would be true about the perimeter would be true? Well, if you triple the side lengths, you're going to triple the perimeter. So which of these would say that? The last one would say that. The new perimeter will be 3 times the old perimeter. Next up, it says, if all 3 dimensions of a triangle are doubled, then which of the statements would be true about the perimeter? Well, again, because the side length ratio is equal to the perimeter ratio, it would also be doubled. So the new perimeter would be 2 times the old perimeter. And oh, never mind. I guess you can only choose one. I thought that this was going to be choose all that apply. You could have also have said the old perimeter is going to be half of the new perimeter, but I don't see any of the statements that say that. This one says the new perimeter will be half. That's not true. So keep going here. Aha, here we go. Okay, so I'm at 81. So technically I would be done if I was doing this, but if you want to continue, any scores past 80 on the S.11 or the T.10 are going to be extra credit. So this one says the figures are similar and it gives you the area of both of these. It says, what is the ratio of the side length of the larger pentagon to the side length of the smaller pentagon? Now, I think there's a way that I should be able to, am I able to draw on this on the screen? I'm not sure. New share whiteboard. Okay, I can share a whiteboard, but I want to write on the screen. I don't know if I can do that. Let me see if I can. Can you guys just see the whiteboard right now? Anybody out there?
Yeah, we can see the whiteboard.
Can you see the problem?
No, it's just a whiteboard.
We
Just a
cannot see
whiteboard. Okay, all right, never mind. Stop that share. Okay, so we'll just have to talk through it. So for this one, and maybe I can use the whiteboard here in a second. It says, what is the ratio of the side length of the larger pentagon to the side length of the smaller pentagon? Okay, so that's again left to right. So it says 98 over 18. So now I'll use my whiteboard because I have to know what numbers those are. So it was 98 over 18. Wow, this is really bad with my mouse. And that was the area ratio. Well, first thing I notice is that needs to be reduced. And so I can reduce this by 2 to get 49 over 9. Okay, so that's the area ratio. Let me say this is the area ratio now that we've reduced it. Okay. Now, what's the side length ratio? Well, since the area ratio is the same as the square of the side length ratio, that just means I have to work backwards here and square root both these numbers. And so the side length ratio would be 7 over 3. So I just have to work backwards. So if you see problems like that, work backwards. Now, if you would have seen a problem where they give you the perimeter ratio, so let's say the perimeter ratio is 5 to 3. And it wanted you to give the side length ratio. Well, since I know the perimeter ratio is equal to the side length ratio, I wouldn't have to square root anything. It's only when they give me the area ratio that I would have to square or square root it if I'm working backwards. Okay. So before I move on to today's IXL, does anybody have any questions over the S.11 IXL that you might currently be working on? Okay, so I'm going to now start talking about the T.10 IXL that is actually tonight's homework. So S.11 is due tomorrow. This T.10 homework isn't technically due until 2:30 on Thursday. However, you have a quiz over this. So ideally you would get both these IXLs done, have them done by the time you take that quiz tomorrow afternoon. Okay, so let me share. I'm going to go back to my iPad screen again and pull up T.10. This one is equivalent to the 8.4 homework that's actually due today, which was titled Surface Area and Volume of Similar Solids. Okay, 2 fingers to scroll the question. Excellent. The figures below are similar. It wants to know the ratio of the surface area of the smaller cone to the larger cone. Well, right now the side length ratio is 2:4, which reduces to 1/2. So there's my side length ratio. I know that the area ratio, whether it's area or surface area, it doesn't matter, is going to be the square of the side length ratio, and that is going to be equal to 1/4. So area / surface area, you square the side length ratio. So it wants me to not draw a line. What does it want me to do? Write it, separate. Ooh, separated by a colon. Well, you have to know what a colon is. Good thing they give you an example right there. So I would write 1, 2, 4. Okay, this one's asking for the volume ratio. So the side length ratio is 4:6. And then, so if I reduce that to 2/3, that's my side length ratio. The volume ratio is going to be raised to the 3rd power because volume is in cubic units. So perimeter, 1st power, nothing changes. Volume, area and surface area are 2nd power, so we have to square. Volume, we have to cube. And so this would be 8, because that's what 2 times 2 times 2 is, or 2 to the 3rd. And then 3 to the 3rd is 27. So now I'm going to make sure I've got it written the right way. Watch out for IXL. They can be tricky. This one says smaller to larger, but they could easily flip it around on you and say larger to smaller instead of smaller to larger, and that you would just flip the order of the numbers around. So this is going to be 8 to 27. Okay, what is the ratio of the volume? Okay, so the side length ratio is 2/3. If I cube that side length ratio, that will give me the same answer I had before. I'm not going to do all that work again, just 8/27. Okay, this one is surface area. And so it says the larger rectangle to the smaller one. So I do want to go in that order. So 2/1 is the side length ratio. The surface area ratio is going to be the square of that side length ratio, which will be 4/1 still, because 1 squared is still 1. So 4/1 or 4:1. Ah, there we go. Good. I was wondering when they get one where I have to use a proportion. Okay. So for this particular set of cylinders, I know the side length ratio is going to be 4:8, which is equivalent to reducing that to 1/2. That's the side length ratio. The area ratio is going to be the square of that, because I'm doing surface area here. It's nice they use S and V for surface area and volume. And so that's going to be 1/4. Okay, but that's not my answer here. My answer is, what is the actual surface area? So this is where I can use that ratio now. If my surface area ratio is 1/4, the proportion I would set up is I would start by putting the smaller surface area on top, which I don't know. So there's my X because it's missing. And I would put the larger surface area on bottom, which is 676. Sorry about the writing there. This is IXL. They need to fix their writing system. And then I'm just going to cross multiply that. And so 4x equals 676 times 1, which is still 676. And then divide 676 by 4. And that's going to give you 169 centimeters squared. Okay, and we'll do one more example. This is finding volume. So the side length ratio is 6/9, which reduces to 2/3. I think I could just start there and you guys would be okay with that. So that's my side length ratio. The volume ratio is going to be the cube of that. So we keep getting the same ratio because this is just going to give me 8/27 again as the volume ratio. Then I can use my proportion of 8/27. I can write down the volume of the first one, which is unknown. The reason I'm doing the first one is because the 8 represents the first shape and the 27 represents the second one. So X, and then I'll put 729 as the volume of the blue larger rectangular or triangular prism. And then cross multiply that. So 27x equals 8 times 729. I didn't have enough room to write that. 5,832. Sorry, that looks like trash. Divide by 27, and that's going to give you 216. Okay, now I'm going to use my computer and advance a little bit. So we can look at some more complicated problems for those of you that are close to 80 or that want to go beyond 80. Okay, so T10, let's go beyond this. Let's see what happens when you get to a smart score of 60, nothing special. Okay, now I'm at 81. And I've got a problem that looks like this where they're asking me for the missing side length. Okay. It says the ratio of the triangular prism's surface areas is 9:25. What is Q? Okay. So the first thing I would do, this is note that this is surface areas. And so I know that this ratio of 9/25 has been squared. And if I square root it, that would give me the side length ratio. Also, I need to know that this is Q and this side length is 5. So now I'm going to pull up my whiteboard. See if I can, I wonder if, let me try something. If I can like copy and paste my picture to my whiteboard. Clear all drawings. And can I paste something? Okay, I cannot paste something. Well, shoot. Okay. So let me write down so it was a triangular prism, had a side length of Q, and then there was a larger triangular prism, had a side length of 5. It says the surface area ratio is, I think it was 9:25. It is 9:25. Okay. Oh shoot, where'd my whiteboard go? I didn't just delete it, did I? There it is. Okay, can you guys see my whiteboard? Can someone confirm they can see this before I do this all?
We can see it.
Okay, thank you, Carter. Okay, so what I'm going to do is I'm going to write down my surface area ratio. And I need the side length ratio. So I'm going backwards because instead of having you find the surface area, this one's having you find the side length Q right here. And so we're going to unsquare this, which means we're going to square root it, right? And so that gives us a side length ratio of 3/5 as a side length ratio. So we went from the area ratio to the side length ratio. And then now I know that 3/5 has to be equal to, go back to the first shape, Q over 5. Well, it's pretty obvious now what Q has to be. Q would have to be 3 for this ratio to be consistent. And so we could close that, type in 3, and move on. Okay, this one's having you, what is the ratio of the height of the smaller cylinder to the height of the larger cylinder? Okay, so I would write down, so the volume ratios for this one is 27 to 64. That's smaller to larger cylinder, 27 to 64. That's the volume ratio. If I want the side length ratio, so it says height, right? So that would be a side length. If I want the side length ratio, then I have to do the opposite of cubing. Can someone tell me what the opposite of cubing a number is?
Square cubing?
Not square cubing.
Cube rooting.
Cube root, yeah. So there's square and square roots, and there's cube and cube roots. And so what I would do is I would take that ratio of 27 to 64 and I would cube root it. And you might remember cube rooting from back back in chapter 8 when we had spheres. Remember the volume the volume formula for the surface area of a sphere was 4/3 pi r cubed. And it, obviously we were using our cube button, but if I gave you the volume and asked you to find the radius, you had to cube root it. The cube root, if this is a square root, the cube root has a 3 right there. So some of your calculators have a button that looks like this on it. And maybe it's not even a button. Maybe it's above a button, right? Have the second function. And so I would type in, if I was wanting to cube root 27, I would type in 3. Then I would hit my second function button and then hit that button, because that's going to put the 3 right there. And then I would type in 27 and that would cube root it. And so if I cube root 27, that's going to give me 3, because 3 times 3 times 3 is 27. And if I cube root 64, that's going to give me 4, because 4 times 4 times 4 is 64. So I'd write that as 3:4. That one.
Oh my gosh, what?
Okay, I'll do one last one. What time do we got here? In 2 minutes anyways? All right, got time for one more. Wants me to find out what P is. And it says the ratio of their volumes is 1 to 8. And so it wants to know what the side length of this cube is going to be. So let me get my whiteboard out one more time. Okay, so I've got a cube, a side length of X, and then I've got another larger cube. I'm not going to draw the whole thing. That's not even a cube. Wow. Okay, whatever. Has a side length of 2. And it said was it volume? Yes. The volume ratio is 1 to 8. So I know that I'm not used to using Zoom's whiteboard. Okay, so I know the volume ratio is 1/8. And if I cube root that, just like I did last time, that's going to give me a side length ratio of 1/2. That means I can use that 1/2 as my proportion. So 1/2 has to be equal to, and then I'll go and I'll put that side length to that side length, which is X over 2. And that's going to be a piece of cake, because that means X has to be 1. Okay. So here's the deal. Sky, you have a question.
Yeah, I needed help on a problem.
Okay. So here's what we'll do. I've got a little bit of time. It's 12:50 right now. My next class doesn't start till 1. If you have a question, stay on and I can help you. And if I don't have time for your particular question, I can help you with your Sky. Then come see me or come Zoom with me during my office hours from 1:30 to 2:40 today. and or 220, 240, I forget what it is. I think it's 240. So this is your homework for the last 2 days. Get S.11 done for tomorrow and see if you can get T.10 done for tomorrow so you're ready for your quiz. You guys are dismissed. Stay on if you have questions.